I built a machine learning model with 94% accuracy and it completely failed in real life. That's when I discovered a hidden mistake called data leakage and everything changed. In this project, I don't just predict customer churn, I show you why accuracy can lie and how metrics like recall and precision actually drive business decisions. From fixing the pipeline to tuning the perfect threshold till comparing multiple models in real time. This is not just another ML project, it's how you start thinking like a real data scientist. Let me show you how this project works in action and how all these decisions actually play out in real time. Hello guys, welcome to my YouTube channel. In this video, I will be demonstrating my next project which is of customer churn prediction. Now, without wasting any time, let's directly start project demonstration. So I will simply click on this address bar and type cmd, so that command prompt will open in this folder. And as you can see, the command prompt has opened successfully. Now the first step is to activate virtual environment. So the command to activate virtual environment is vnv/S scripts/activate. As you can see, the virtual environment has got activated successfully. For your information, this is Flask application and the command to activate the Flask app is Python app and the file name is app.py. So I will simply hit enter and it will simply give us a URL where the Flask application has become activated, and I will simply control click on this URL. And as you can see, this is a beautiful user interface of Customer Churn Prediction project, and I have given a basic title as Telco Churn. Now before directly jumping into project prediction, I would like to give basic idea about what customer churn really means. So the definition of customer churn is that customer churn occurs when customers stop doing business with your company or they cancel their subscription. The main goal of this project is not just prediction, but actually preventing customer before they churn out. The idea is simple. Using machine learning, we can identify customers who are likely to leave, so business can take actions before they lose them. And why this step is really important? Because in most of the subscription-based business, retaining a old customer is much more cheaper than acquiring a new one. So instead of reacting after churn happens, we shift towards proactive approach, where we will identify a customer before he actually opts out of your company or business. So this was the basic idea of this project. Now let's directly launch the prediction tool and explore the project demonstration. And as you can see, this is a beautiful predict customer churn page where I have filtered out the top 8 features using which we can identify if a customer is going to leave or not. So moving ahead, first part is model selection, and as usual I have used 5 models: balanced random forest, XGBoost, random forest, AdaBoost and Logistic regression. So let's select the first best overall model, and here are the most important feature, which is contract type, which means the subscription is of yearly or month to month. You can simply compare this with the mobile recharge that we do monthly subscription or yearly subscription. The next is payment method, and here are the options: electronic check, mail check, bank transfer, credit card. These are the type of payment method. Coming next is the internet service, which is fiber optic, DSL or no internet service. The next is has partner. The main motive of adding this feature is that if a customer is dependent because of 2-3 other dependent members like his family, so he is most likely to stay because he is dependent on multiple decisions by multiple people. Coming next, here is the paperless billing. So means is the billing online or offline. The tenure. The tenure means since how much time the customer is with us, and what are the monthly charges that he pays, and what are the total charges that he has paid till now. So to test this project, I will directly use the raw data that I have taken from the telecom dataset. So let's simply go to the folder structure and open this data folder and use the sample test data. So as you can see, these are the 8 records and the final prediction output. So let's test for this record. Now I will quickly add this feature in the predict page. As you can see, I have added all the features of first record, which are contract type was 2 years, payment method, bank transfer, internet service was no, has partner yes, paperless billing no, tenure was of 61 months, and monthly charges are 25 and total charges were 1500 or 75. You can verify it from here, which is this, and the customer has likely to stay. So now let's test this. So I will simply click on this button and it's analyzing, and the answer is no churn expected, which means that customer is likely to live longer with us. So this was for the customer who is not able to churn. Now let's simply test for the customer who is able to churn. So the different case in our example is this record, which is third record, and I will add all of these features in the predict page once again. As you can see, I have once again added the features, and the information of the customer is the contact type was of month to month, payment type was credit card, internet service was fiber optic, and the person had partner, paperless billing yes, the tenure was 13 months, which means the customer has recently started using your service. The monthly charges was 102, which is comparatively high, and the total charges that the customer has paid is 1358.99. Now let's simply click on this prediction button to see the output. And as you can see, the output is churn likely. The customer is at high risk of leaving. Consider immediate proactive engagement or tailor offers, which means simply try to give offers to that customer so that you can retain this customer. This was all about normal predict function where we input feature one by one and test the output. And apart from this, I have created a batch predict mode where you can simply upload the CSV or Excel file and see model comparison. So let's explore that part of the project. So I will simply go on this batch predict button, and this is the web page of batch predict and model comparison. Here you just need to upload the CSV file or Excel file, ensuring all the 8 features are in correct sequence. So let's test it. I will simply upload a sample test file from which we just use the features for manual prediction. So this was the sample test file, and I will simply open it and simply click on this button. And as you can see, the output is in front of you, starting from performance summary on uploaded data. And the output is logistic regression, which is best for catching churners, which means the logistic regression model has 100% accuracy to catch the people who are going to leave. But during catching such customer, it may catch few customers who are not likely to leave. So this is drawback of logistic regression model, because the recall of that model is very high and precision is low. And coming next, which is the most accurate prediction, which is balanced random forest that we use in manual prediction, and the accuracy is 81.82%. Moving forward, here are the matrix comparison of all the models. The accuracy of logistic regression is only 24% because it has identified most of the people who are not likely to leave. The next is random forest with 74% accuracy, and recall is of 83%, which is really good, followed by precision, which is 47%. Moving forward, the next is XGBoost model with 74% accuracy, 75% recall, and 47% precision. Moving ahead, the next is AdaBoost model with 70% accuracy, 75% recall, and 42% of precision. And here comes the best model, which has 90% accuracy, which means this is the most balanced model, which evenly classifies recall by 75%, precision by 81%. So this was example of batch predict web page where you can simply upload your file and see the output. You just have to ensure that the feature list is correct to 8 features and the expected output. So this was all about my entire project demonstration. Now let's simply move to understand the technical details and architecture of this application. So I will simply go to home page once again, and I have already given you a basic idea of what customer churn means. So let's simply scroll down, and now let's simply focus on the strategy that we can generally follow to retain our customer. First is proactive engagement. Reach out to high-risk customers before they initiate cancellation. Second is trailer offer. Provide personalized discount based on customers' usage pattern, flexible contracts, enhanced support, and loyalty programs, in which we can simply reward a long-tenure customer to reinforce their decision to stay. Now let's move ahead. And here comes the machine learning dilemma, which is there is no single best model. The right model depends on your business goals, whether you want to catch as many churners as possible or avoid false alarm. This is where the decision between the logistic regression and balanced random forest does. If you want to catch all your churners, logistic regression is best model. But if you want to avoid false alarm, then you can simply move to the balanced random forest. So this was all about the home page. Now let's simply move to the dataset page, where I will give information about the dataset and the features that I used. So let's simply click on the dataset button, and as you can see, this is the dataset overview. This dataset contains around 7040 customer records, and the dataset is heavily imbalanced with around 75% of people who stayed and only 25% of people who left. During model training, I didn't use all the available features blindly. I focused on identifying the most impactful ones, and after my analysis, I narrowed down from 20 to 25 features to directly 8 features that actually have high impact in making churn predictions. For example, the customer month-to-month contacts tends to churn more frequently, And as you can see, this is the output of that, in which you can easily see that the people who take month-to-month contract have 42% probability to cancel the subscription or leave your business. Moving ahead, the customer who pay by electronic check have high frequency of leaving, which is 45%. And interestingly, even the fiber optic user have high accuracy of churn rate, which is this. As you can see, the fiber optic users have 41.9, and these customers have high probability to leave your service. So these were the main features who highly impacted the customer churn prediction. Now let's simply explore the features that I optimized for you. The first one is contract type, which is monthly, non-monthly, that we just discussed. Second was payment method. Third was internet service, that I demonstrated you. The next is partner, whether the customer has partner or not. This is very, very important, because if a customer has partner or spouse, he is likely to stay with us because he is dependent on decisions of multiple people. The next is paperless billing, if the customers receive digital bills instead of paper. The next is tenure. If the customer stays with us for a long amount of time, he is less likely to leave our service. The next is monthly charges, which means the monthly charges that customer pays. And finally, the total charges, which simply means that up till now how much the customer has paid to us. Moving ahead, let's simply explore the other features, which was this. We simply says that the senior citizens are likely to leave the service, but this didn't help me a lot. That's why I have not included this senior citizen feature. The next is the monthly charges distribution. And if you can see, if the monthly charges is less, up to $20, the person is likely to stay with us for a longer period of time, and as the monthly charges increases, the probability of that person to leave our service increases. Moving ahead, here is the sample dataset that I have just created for you so that you can explore how the data looks like. The contract is in textual format, payment method is this, internet service yes, no, fiber optic or DSL, tenure in numbers, monthly charges, paperless billing, total charges, partner, and last options of churn or no churn, which is our expected output. So this was all about the dataset page. Now let's explore the models page. And as you can see here, I have added the beautiful card visual, using which I will try to explain you what does the metric means to us. So let's click on this first metric, and I have tried to explain the meaning of each of the metric. First one is precision, which simply answers the question, out of all the customers who predicted to churn, how many actually did? In this situation, the logistic regression fails a lot. The next is a recall, out of real churners, how many did we catch? Next is F1 score, which is a sweet spot for balancing precision and recall. Next is ROC and AUC curve, which simply tells that how accurately the model distinguishes between churners and stayers. So this was the basic explanation of the metrics. Now let's simply move to the each model's analysis. So as you can see, the precision was only 49% for logistic regression, recall was 80%, due to which it was confidently classifying all the churners, and F1 score and ROC curve. Moving ahead, the next is random forest, which has precision of 53%, recall of 67%, F1 score of 59%, and so on. Moving to balanced random forest, precision is of 53%, recall is of 62%, and so on. XGBoost, precision of 52%, recall of 66%. And the last is AdaBoost, which has precision of 50%, recall of 71%, and F1 score of 59%, due to which the accuracy is of only 73% of AdaBoost. And here I have tried to answer your main question, which model we should use. First is logistic regression model, which is best for non-missing any churner. The next is random forest, which is best for accurate targeting. After that, here comes the XGBoost, which simply says best overall model, which has balanced performance. The next is AdaBoost, which is best for aggressive detection. And the final comes the most imbalanced aware model, which is balanced random forest, and this model is best for imbalance handling. And after that, here are the visual output of all models, which is accuracy of all models, next recall for all models, followed by precision, ROC-AUC, and F1 score. As you can see, you can simply take a look on them just by pausing the video. So this was all about the model page. Now let's simply go to the about page, where I have added aim, objective, and scope. The aim of this project was simply to develop a robust ML app to predict telecom customer churn. The objective was simply to analyze data, compare classification model, and deploy web app for prediction. And the scope was end-to-end ML pipeline using EDA, evaluation, and interactive fast deployment. And I have achieved all this, as you can see. And here is the dummy data of the team members. So this was my entire project demonstration. Now let's simply understand the folder structure that I have maintained for this application. So I will simply open the folder structure, which is this, and let's simply move to the base folder, which is this. So let's start from the first folder, which is app folder. In app folder, you can find static templates and app.py file, which we executed right now. The static folder contains the CSS files and the images that I just demonstrated to you on the user interface. Moving ahead, this is the CSS file which helps our application to look beautiful. Moving back, here comes the template folder where HTML code of every web page is present, starting from about, base, batch predict, dataset and other web pages. Moving ahead, this is the app.py file which is execution point of our application. Now let's simply move one folder behind, and next folder is data folder where our raw data, which is this, and sample data is present that we just use in project demonstration. Moving one step back, here are the models folder where all the 5 models along with the features and scalar files are present, totaling to 7 files. Now let's move one step behind. Now this is the notebook folder where only one Jupyter file is present, and this file is the backbone of this project because in this file only I followed a full ML pipeline and created this project. This is the virtual environment folder in which our current application is running, and next is the project documentation.md file which contains the documentation of our project, and finally the requirement.txt file which contains the list of packages that are necessary to get installed before executing the application. This was explanation for folder structure. Now let's simply move back to application. So this brings to the end of this project, and before concluding this video, I would like to highlight one important thing. This project was not at all about churn prediction. It was about understanding how machine learning model works in real environments. During this project development, I focused on building a proper pipeline, balancing the dataset correctly because dataset was highly imbalanced, and testing the application on multiple models, and most importantly shifting my focus from accuracy to business metrics like recall and precision. I also learned that there is no single best model, but each model has its own specialty and it can be considered as best for different scenarios. So this was my entire project demonstration. I would also like to know that what you learned from this video. Do let me know your thoughts about this project in the comment section below. And here comes the end of this video. Thanks for watching this video, and I will catch you in next video with next project demonstration. Thanks for watching.